Hello guys, I hope you are fine. Me too, I'm fine. So guys, we are so grateful to God for giving us yet another opportunity. Guys, I do not cease to thank God because God is good. So guys, just understand me because that is appropriate. And so guys, we come and look at the question, and let me read the question. Determine the stationary points of the function below and state their nature. So here guys, we are given an equation. So what we do guys is that we want to determine the stationary point, meaning that we have a graph. This is actually will form a graph. And this graph can be drawn on a Cartesian plane coordinates with Cartesian coordinates. But now guys, we are going to do it analytically. And how do we do it? First of all, guys, we look for the derivative, because what happens, guys, for the stationary points, we would have a movement whereby the gradient becomes zero, because for it to be a stationary point, it will be as though the point is moving in such a manner that either that point can be moving this way, and then when it reaches at a certain point, it now goes back like that, meaning that our stationary point is somewhere at that point. Or we can even have a line moving like this, and then when it reaches at that point, it goes up, meaning this can also be a stationary point. Or even it can go like this, guys, whereby it moves like this and then it moves like that. So this one, all of them, we call them stationary points. And so guys, you can see at the stationary point where there is no movement upward, or where it goes back, it's like it is going back. Guys, it's like a vehicle moving in a straight line like that, and then for it to reverse, it has to stop even for a moment so that it can come back. So the moment it stops, we can call that a stationary point. So for us guys, our stationary point, then it will be at that point where the derivative is zero. So we shall now look for the derivative for that. That is the first thing. So we shall come and say dy all over dx. This one now gives us the dy dx. For that will give us x squared minus, for this one you'll have 2x, and then we have minus 3, and then the dy dx for constant is 0. So this is what now guys we are supposed, now it is supposed to be 0, because as you see, if you look at that point, you find the gradient is actually 0, because you form a straight line like this, of which a horizontal line like this, of which a horizontal line guys gives us a gradient which is 0. So for us guys to find that point, we would have to solve this equation. And this equation, maybe I can write it down here, is x squared minus 2x minus 3 equals to 0. So this forms a quadratic equation. So let's solve it and see our values for x. So we look for two numbers. If you multiply, you get negative 3. If you add, you get negative 2. Those two numbers are negative 3 and 1. Because if I multiply those two numbers, you get negative 3. If you add, you get negative 2. So we shall write here x squared. I can start with a minus 3x plus x minus now 3 is equals to 0. Then we can divide, guys, this equation you can divide into 2, like that. So guys, we are just solving the quadratic equation as it is. You can factor out x. So if we factor out x, guys, we are left with x minus 3 plus, here we are going to have 1, then x minus 3, this one is 0. So finally, guys, we have x plus 1, x minus 3 as our factors. This is equals to 0. So we can say either x plus 1 equals to 0 or x minus 3 equals to 0. So here we have x will then be equal to -1 or x is equals to 3. So those are our values, guys. So we have been able now to find our values for x. So at this point, guys, we have our value, assuming that this is our Cartesian graph. So we've been able to find x. And as you can see, there are 2 x's. So even this one, guys, still has its own x. But now we have not done the proper graph. That's why I may not use that. But we have been able to find our value of x. So now we go to our graph again and now find our value of y from this, because remember that fx is the same as y. So I can write the equation here. Y is equals to a third x cubed minus x squared minus 3x plus 7. So we can say when, I write here, when x is equals to -1, let's now find what is y. Shall have a third -1 raised to 3 minus -1 for this raised to 2 minus for -1, then it will now be 3 here plus 7. So guys, this one we are going to have it as, since I already have calculated it, the value for that will be 26/3. That is in terms of fraction. So our point, that is the stationary point, then is going to be -1 and then 26/3. That is one of our point, guys. Point. Let me write point like that, or the stationary point. Let's now come and look for the other point when our x is equals to 3. So we say when x is equals to 3. So for that one, you can do it right here. You have 1/3, then you have 3 cubed minus 3 squared for that minus 3 multiplied by 3, that is minus 3 multiplied by 3 plus 7, like that. So guys, this one is going to be, after the calculation, guys, I was able to find -2. And so guys, our point is 3 -2, like that. And I think it's even easy to find it, because for this one you have, this one will be now be 9 minus 9, which is 0, minus 9 plus 7, which is negative 2. So that one, guys, is easy to understand or to calculate. So guys, the next thing, guys, we are going to find out is the nature of our points. So I write the nature of the points. So for that one, guys, we come and we differentiate yet again. That is our dy dx. We now do the second derivative. And it is here now, guys. This one we do the second derivative. And the second derivative is going to be d squared y over dx squared. This now gives us 2x. So I write there 2x. This one now will give us minus 2. So that's how we do that. And so for us to find the nature of the point, if when we place our x, for example, with negative 1, we find the solution is negative, then that point is a maximum. So that now, guys, if we have 2 there, we place with the negative 1, minus 2. This gives us minus 4. So this one is a maximum. Sometimes we call it maxima, but it's maximum like that. So we can say point, can put there point, that is point 1, negative 1, to 6 all over 3 is maxima, point, maximum. Maximum meaning it moves like in this manner, like that. Then we go to the point number 2. For the point number 2, which we have x as 3, it shall be 2. We replace x with the 3. Now minus 2. That will give us 6 minus 2. This one is 4. So this one we call it a minimum point. The minimum point is 3, negative 2, like that. That's the minimum point, and this point is like this. That is the point. That is also the point. So guys, our second point, that is coordinate with coordinate 3 and negative 2, is actually a minimum point. And so guys, as we come to the end of the topic, I was able to draw the graph. And let's now look at the graph and see what really happens. And here, guys, is my graph. So if you look at it, guys, what you see is our original graph. Before we come to derivative, this is our original graph. And you can see at this point is the maximum point. That is the maximum point, and we have the minimum point. So I was asking myself, why do we have to differentiate again? And the reason, guys, I found why we differentiate, let me say this. This is the first derivative. For this is the first derivative. You can see that line running with the red dotted line, our spaced line like that. This one is our first derivative. Now, guys, I want to observe at our minimum point. If you observe at our minimum point, this line moves in this, is inclined in this manner. So guys, if we were to do another derivative, that is the second derivative, it means the derivative of this line will be a positive. And you can see this line, the point of that is the stationary point coincide with that line. And so that's why now you can see that if we get the second derivative, it will be positive, and then it means it will be represent the minimum point. Going to this other point, this being our first derivative line, if we were to differentiate it, you can see the line is inclined this way, and if you find the derivative of such kind of a line, you get a negative derivative, and that's why now you see this one becomes a maximum point. So that's what I was investigating when I was drawing this graph. I have not drawn for the second derivative, but by just looking at it, this one is a negative. It will give us a negative result. This one will give us a positive result. And so guys, we come to the end of our lesson for today. So guys, have a nice time. Bye bye.